All right, so we are at 6.4 part 2. And we're still looking at the quadratic formula. So example 3, connect a parabola with no real roots. So we're connecting parabola, but we're also looking at something that has no real roots. So a parabola has equations, so we're looking at a vertex form. Y equals x minus 2 all squared plus 3. So state the coordinates of the vertex, the equation of the axis of symmetry, and the direction of opening. B, determine the x-intercepts, verify using the quadratic formula. And C, sketch the parabola. So A we know quite a bit about because we're already in the vertex form. So we need to remember that our vertex form is y equals ax minus h all squared plus k. So our h, again, is the opposite sign of what we're seeing, and our k is the same sign as what we're seeing in the formula. So our vertex equals 2 and 3. The equation of the axis of symmetry. Well, an axis of symmetry is always the x-coordinate of our vertex. So our axis of symmetry is x equals 2. So it is an equation, x equals 2. And the direction of the opening, we know that because there is a positive a, the a is just 1. So we know, that it opens up. So we already know that we are going to have 2, 3 as our vertex, and we know we're going to open upwards, and that our axis of symmetry is x equals 2. So we've already got most of our sketch all ready to go here. So we know from all of this information, since it opens up, since the vertex is above the x-axis and we're opening upwards, we know that it does not cross the x-axis. So there are no real roots in this equation. So that is our B. Determine the x-intercepts. So we know it's going to have no real roots, so we know it's not going to have a x-intercept here. So we can already start drawing it. Let's do 2 lines per. 1, 2, 3, 4. 1, 2, 3, 4. So we have got our axis of symmetry being 2. We've got our vertex of 2, 3. And we know we're opening up. We also know that because we have no A, in here, so since there's no A or A equals 1, we know that our up and over pattern, our pattern of kind of our rise over run, is going to be 1, 3, 5, 7, 9, etc. So we already know if we go over 1, we can go up 1, go over 2. I guess I should have started lower. We can move up like that. So we already have some of our information in there. And if I want to show you another way, so look at that, and then I want to show another way. Let's graph this a little bit differently. So it's smaller. And we'll go so our vertex at 2, 3. axis of symmetry, x equals 2. And again, over 1, up 1, over 1, up, over 1, up 3, over 1, up 5. And we've got a nice smooth parabola going there. So another way to do this, so first of all we need to finish B. So B, determine the x-intercepts, verify using quadratic formula. So we know, since we've got a vertex of 2, 3, and we're opening up, that we're not going to have an x-intercept. But we want to verify this using the quadratic formula. So minus B plus or minus the square root of B squared minus 4AC all over 2A. And really, all we need is this bit in here, because we know that if this is greater than 0, that we have 2. If we have 2 real roots, we're going to cross the x-axis 2 times. If that is 0, we're going to just touch the x-intercept and only cross it 1 time. And if that's negative, then we're going to see, like our chart here, that we're not touching the x-intercept at all. So I already know that that's going to be the answer. But if I use this and I fill in, so we need to first figure out what our equation is in standard form. So let's separate this and make some more room. So I need to figure out what standard form is. So I need to expand this. So I can use our a minus b squared equals a squared minus 2ab plus b squared, or I can just FOIL that to figure out what my next line is. So a squared is x squared minus 2 times 2 times minus 2 times 2 times x is 4x plus b squared plus 4 plus 3. And then, of course, simplify that. To get our standard form. So now we've got a equals 1, b equals -4, and c equals 7. So I can verify by doing -4 squared. Remember to keep the negatives. A is 1 and c is 7. So I've got 14 minus 4 times 1 is 4 times 7 is 28. So I've got a -12. So we know that if is greater than, or sorry, less than 0, then we have no real roots. So we verified using the quadratic equation. In the textbook, it goes through this entire thing in order to get it, but you don't have to do the other math. It's just what's under the square root sign that's important, that tells us, because that's negative, then we have no real roots. So the other way that you can find more than one point on this, besides knowing the 1, 3, 5, 7, 9 formula, is knowing that our C is our y-intercept. So if I didn't know the pattern, I would know that 0, 7 was going to be a point. And then by using my line of symmetry, knowing that I've got using 2 over in this direction, I need to move 2 over in that direction, and I've got a point of 4, 7 also on this graph. So the 1, 3, 7, 9 times our A is a better way, or an easier, faster, more accurate way, but also knowing that what our y-intercept is and then finding its mirror is also a way to put points on the graph, or at least to verify what you've done is correct. Solution in the book, like I said, they went through the entire formula. I'm just concerned about what's underneath the square root sign. So looking at the x-coordinate of the point, I know that is located 2 units to the left of the axis of symmetry. So I know that the axis of symmetry is x equals 2. I've got a 0 here, so I've got to move 2 over. So now I'm moving 2 over again. That's how I found the second point. Example 4, path of a basketball. The path of a basketball after it is thrown from a height of 1.5 meters above the ground is given by the equation h equals negative 1/4 d squared plus 2d plus 1.5, where h is the height in meters and d is the distance, horizontal distance in meters. So again, if we're drawing it, our d becomes our x for distance, and our h becomes our y, and it stands for height. So we know we're starting off at 1.5 meters. Zero, 1.5. Being right there. We know we've got a negative arc on our parabola, so we're opening down. So it's probably going to go up a bit and then come back down, but we don't know. It could go straight down or it could go looping down. It's going to look something like that. So I just like to draw it at first so we have some understanding of what's going on. How far has the basketball traveled horizontally to the nearest 1/10 of a meter when it lands on the ground? So what is that actually asking for? Its landing point. What's its landing point? Is our x-intercept, or roots, or zeros. That's what that's looking for. And then we'll tackle B after. So how far has the ball traveled horizontally to the nearest 1/10 of a meter when it lands on the ground? So what we're asking for is when h equals 0. So we want to use our quadratic formula because that's what the position we are in. So our d, our h's become d's, or I mean our d's, our h's become 0, our x's become d's. So we've got negative b plus or minus the square root of b squared minus 2ac. Say it aloud every time you write it down so that you remember it. Remember, I've got 2 a's, 2 b's, and 1 c. It's another way to remember it. Fill in our information. Make sure the negative is on the outside. Our a equals negative 0.25. Our b equals 2. And our c equals 1.5. So we got some decimals working out here. So we're going to have some calculator work. So we got a negative 2 plus or minus the square root of 2 squared minus 4 times negative 2.5 times 1.5, all under the square root sign, all divided by 2 times negative 0.25. So it looks complicated at first. If you want to color code it to make sure A's and B's and C's are easy to see, go for that as well. If you need to rewind and see how I do the math or ask about that, go for it. So we keep our plus and our minus underneath the square root sign. Again, I can do this section and this section at the same time without messing anything up. So I like to do that a little faster. So this is actually going to change to a positive because we've got a -4 and a -0.25. So 0.25, 1.5, and 4, we multiply them all together. We end up with 1.5 because that -quarter and that 4 kind of cancel each other out. All over -0.5. And try and fit one more down here. So we end up with -2 plus or minus, too small. So we end up with -2 plus or minus the square root of 5.5 all over -0.5. So really we've got two of these. And again, this will be calculator work. We've got plus the square root of 5.5. Most calculators, you have to do the square root sign first and then put in the 5.5. You have to know how your calculator works. Oops, and this one is minus. (5.5) all over negative. And so those that -2 and that -0.5 do cancel each other out. We could have done that as well before this point. So by doing this on the calculator, you might have to put it in as brackets -2 plus the square root sign, then 5.5 brackets, and then division, and then -0.5. Make sure you know how your calculator works. What buttons do you have to press in what order? What things do you have to put in brackets in order to do this? If you need help with your calculator, please talk to me. So that ends up being, and again, it's an approximate number. This are our exact roots. But we can't graph our exact roots. Those are the 100% accurate numbers, but we can't graph that because we don't really understand what that means. So we put that little dot on the top that says it's approximate, and they've asked us for a tenth of a meter. So we've got -0.7, and we've got a distance of 8.7. Now obviously the basketball went forwards and not backwards. So the negative number doesn't make any sense. Because it did not go backwards. So that is this number, if we continued our parabola backwards. But we obviously did not throw it backwards. Otherwise it would have said you stood backwards. So we're going to discontinue that one, or discount that one. And we need to, of course, write a sentence, as always. The basketball traveled 8.7 meters before it hit the ground. So that is our final answer right here. So that is how far it hit the ground. So if we were going to put this in here, 8.7 and 0 is our other point, whereas -0.1, sorry, 0, oh, that's right, goes in there. So find the horizontal distance when the basketball is at a height of 4.5 meters above the ground. So we've never done these ones before. So what this is asking for is, again, we've drawn our guy here. We know that we started off at 1.5 meters. It's gone up, it's gone down, it's gone 7.8 meters. 8.7 meters. Right here is 1.5 meters high. Didn't drop that high enough. But it's saying that it's gone up quite a bit and gone down quite a bit. This is quite the air time on his jump shot. So what it's asking for is at 4.5 meters, how high is it? So it's possible that that's the vertex and we've only got one point. So maybe it looks like this. Or maybe it looks like the blue line and we've got 2 points. We want to know how high is it when it is, or how far horizontally it is when it is at 4.5 meters. So what is our x, or our d, when our height is 4.5 meters? So we need to put that into our h. So now we have 4.5 equals negative 0.25 d squared plus 2d plus 1.5. So rather than making our h 0 like we're used to when we're finding our zeros, finding our x-intercepts, now we want to know what is d when height is 4.5. So we can't leave it like this because we need to have a 0 equals in order to use our quadratic equation. So we need to move that 4.5 to the other side, changing its sign to a negative and subtracting it from 1.5. So we end up with a new number of negative 3. So now we have an a that still equals negative 0.25. We have a b that still equals 2, but now we have a c that equals negative 3. So we're using a different collection here. So because I don't have enough space, I'm not going to write out the formula with the a's and the b's and the c's again. So d equals negative b, which is 2, plus or minus the square root of b squared, which is still 2, minus 4a, which again is 0.25, and c, which is negative 3, all over 2, and a is negative 2.5. So some of this we've already calculated before. We're still at negative 2 plus or minus the square root of 4. Our 4 and our negative 0.25 cancel each other out again. So we've just got the negative 3 left over there. And our bottom is the same as before with negative 0.5. So d equals, so our two exact roots and because we can find the square root of 1 is 1, this one's easy to figure out, and we continue on having exact roots all the way till we have a final number. So I'll bring it up here. So negative 2 plus the square root of 1 is 1, all over negative 1/2. And we have negative 2 minus 1, negative 1/2. So we end up with negative 1 over negative 1/2, which again, those cancel themselves out, and negative 3 over negative 1/2. So if we calculate those out, again, the negatives all count each other out. So those two, negative divided by a negative, negative divided by a negative equals positive, so we can get rid of those. 1 divided by 1/2 is 2. 3 divided by 1/2 is 6. So these are both positive numbers. So they're both correct in this case. We're not discounting any of them. But one of them, and actually my graph on the blue line was actually pretty accurate. Get rid of the green line. It was just for show. My graph of the blue line was pretty accurate because what this is saying is this point is at 2 meters and this point is at 6 meters, which is looking pretty good. So we get a point of 2 and 4.5, we get a point of 6 and 4.5. So both of those x's are correct because we've got one going up and we've got one going down. So when the height is 4.5 meters, the horizontal distance is either 2 meters or 6 meters. So we've got two possibilities. It's either 2 4.5 or 6 4.5. We've got one horizontal distance when the ball is still going up. We've got one horizontal distance when the ball is going down. Textbook, pause and read if you like their handwriting better than mine. For B, key concepts. A quadratic equation of the form ax squared plus bx plus c equals 0, where a does not equal 0, can be solved for x using quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The more you say it, the more you remember it. The x-coordinate of the vertex of a parabola is negative b over 2a, and the equation of the axis of symmetry is the same. So that is something we're having a little bit more difficulty finding the axis of symmetry. This is going to help. Homework, page 300, numbers 1 to 2, ACEF, 3 ACE, 4, 5, 6, 7, 8. See you in class.